Welcome to Food Technology 1, FOT150S. I am Vusim Shaisa, and today we're going to be talking about membrane separation. We are going to look at ultra filtration and reverse osmosis. There are different types of membranes or membrane processes that are found out there. There is also filtration, ultrafiltration, membrane, nanofiltration, microfiltration, but for us we are going to look at ultrafiltration and reverse osmosis. This is a continuation of the chapter that we've covered on filtration. So this is part 3 of that series. So if you have not yet watched the 2 previous videos, so I would advise you to go and look at those videos so that you can keep up with us. So now, what is membrane filtration? Membrane filtration membrane separation is a technique that is commonly used in various technological processes in the food industry. We see this in the dairy industry, where membrane separation is used for concentration, standardization of the protein and casein, concentration of proteins in milk, isolation of protein from milk, and moreover, removing bacteria from milk. So we can also use membrane separation in production of cheeses. For example, formage cheese. We can also use membrane separation for production of fresh cheese from sour milk or cream. You remember we've done production of cream, right? We've used cream for production of butter. We can also see that the industry uses these techniques in the juice industry, whereby pectin is removed from juices. Also, starch can be separated using membrane techniques. So now that we know about where these can be used, we'll also briefly look at it in the following slides. But what are the requirements for a membrane? Right? So what should the membrane conform to? Let's look at that in the next slide. 1. The membrane that you use, it must be able to withstand effective cleaning and disinfection to the requirements necessary for satisfactory hygiene operation. So when we clean the process, the membrane must be able to withstand the disinfection, those chemicals that are used in that process, so that your operation can be a hygienic process. Because remember, in the food industry we are producing food for human beings, so that food product should then be produced under hygienic conditions or under hygienic operation. What about the long life of the membrane? The membrane should have a long life in place under the operating conditions experienced. So for example, if you are using high pressure, right, and high flow rates, so your membrane should have a long in place life. So it should last for a longer period of time. It should be durable. So you don't want to use a membrane that will last only for a few hours or for a few days. Right. So the membrane must also be capable of giving the degree of separation required. Because here we want to separate components, it should give us this degree of separation that is required. If we want to separate bacteria from the product, this membrane should meet those requirements, right? Especially at high rates of flow and over extended periods of time. So at longer periods of time, right? And these are the types of membranes. So these membranes may be constructed from a wide variety of materials, including cellulose acetate, right? Polyvinyl chloride, polymers, right? And a variety of other polypropylene materials. I'm not going to go into depth in terms of how these materials are constructed, but for your level, you just need to know that these are the compounds, all right? These are the type of membranes that we found. So we've got the spiral membrane, the ceramic filters, and the hollow fiber membrane. And you can see that these type of membranes, they are different. They are constructed with different materials and they also look different. Each of these materials has different properties with respect to one, the charge on the surface, the degree of hydrophobicity, the pH, and strength and flexibility is different. So, going forward, I would like us to watch a TED Talk by Michael Pritchard on one of his innovations using membrane separation. Let us watch.
That flow through here, and this is the water. But I got to thinking, you know, if we were in the middle of a flood zone in Bangladesh, the water wouldn't look like this. So I've gone and got some stuff to add into it. And this is from my pond. Have a smell of that, Mr. Cameraman. Okay. Right, we're just going to pour that in there. Okay, we've got some runoff from a sewage plant farm. So I'm just going to put that in there.
Hey, there's some poop.
Put that in there we go. And some other bits and pieces. Chuck that in there. And I've got a little gift here from a friend of mine's rabbit. So we're just going to put that in there as well. Okay. Now, the Lifesaver bottle works really simply. You just scoop the water up. Today I'm going to use a jug just to show you all. Let's get a bit of that poo in there. That's not dirty enough. Let's just stir that up a little bit. Okay. So I'm going to take this really filthy water and put it in here. Do you want a drink yet? Okay. There we go. Replace the top. Give it a few pumps, okay? That's all that's necessary. Now, as soon as I pop the teat, sterile drinking water is going to come out. And I've got to be quick, okay? Ready? There we go. Mind the electrics. That is safe, sterile drinking water. Good. There you go, Chris. What's it taste of? Delicious. Okay.
Wow, that was very interesting. So, this is a very, very powerful innovation, and it's particularly also used in the food industry. So, ultrafiltration is basically a pressure-driven separation process governed by the screening principles, and this is also dependent on the particle size. As you would have seen in this video, there is a lot of contaminants that go into this water, and so this Lifesaver bottle contains membranes, and these membranes are what prevents other unwanted contaminants from getting into the water, but the water can be able to pass through, and then it gives us clean water. Right. So, ultrafiltration is defined as the unit operation used to separate solid particles from a fluid by a passage through a porous membrane. Right? So these membranes retain the particles, but they permit the fluid to pass. A variety of filters are available, and the main difference is the pore size, basically. So ultrafiltration membranes are capable of separating larger materials such as colloids, particulates, fats, bacteria, and proteins, while allowing sugar and low molecular weight molecules to pass through the membrane. So perhaps Mdlalose, we are asking, say, what is the pore size of these membranes? So for ultrafiltration, the pore size ranges from 0.01 to 0.1 micrometers, right? So in terms of pore size, they fall within that range. So for very small particles, microfilters are used. So when the membrane pores are capable of separating the molecules of different sizes, then we talk of ultrafiltration membranes. So ultrafiltration is therefore the separation where we make use of ultrafiltration membranes. Let us look at this example here. Let me get a pointer. Right. So if you look at this diagram, I have bacterial spores here and fat globules which are larger than protein or casein or whey proteins, then which are larger than lactose, acids, and non-protein nitrogen, minerals, and we also have water. So then how would ultrafiltration work in this place? Therefore we apply pressure here. If you look at these particles which are larger, there's a membrane here. So this membrane restricts the passage of these components but only allows the smaller components to pass through. So as pressure is applied here in this direction, then these smaller molecules then can be able to pass through, and the larger molecules are separated into the stream, or they are retained. So this is basically what ultrafiltration is all about. So now that we understand a little bit about ultrafiltration, let us try to decipher what is therefore reverse osmosis. In order for us to understand reverse osmosis, we need to understand what is osmosis first. So, osmosis is a natural phenomenon whereby water passes through a semi-permeable membrane from a solution of low salt to a high salt concentration. So you have a membrane, and then on the other side you have salt molecules. So as it is known from your life science, water then tends to move from a low concentration to a high concentration, right, until an equilibrium is established. So these salts, they cannot pass to the other side because this membrane is big, right? It restricts them. So if we apply pressure on this other side where there is a low concentration and reverse the process, we call it now reverse osmosis. Water will be able to go back, whereas these salts, then they will stay. So this reverse osmosis process is used also in the food industry, and mostly importantly in the purification of water. So remember when we started in the year, we had a situation in Cape Town whereby there was scarce water, and then they were talking about day zero is coming, then they kept on postponing it. But one of the things that one of the discussions were using seawater or creating desalination plants. So these desalination plants uses the principle of reverse osmosis in order to purify the water. Right. So how does this reverse osmosis differ from ultrafiltration? The difference is that the separation of similar sized molecules may be obtained by the use of specific membranes such as thin films or cellulose acetate. So in membrane separation processes, reverse osmosis is concerned with the separation of different molecules of low molecular mass of a size comparable that of water molecules. As it can be seen, it's the pressure that is applied that is different in reverse osmosis. So if we look at here, now we've looked at the ultrafiltration on this side, so we still have the same thing, but now in reverse osmosis the membrane will only allow the passage of molecules similar to the size of water, or only, simply put, low or water molecules. So this is basically how it will then go. So if you look at ultrafiltration, you still have proteins here, which are lactose acids, non-protein acids, and then you've got also minerals. But with reverse osmosis, you are only extracting water or similar sized molecules. Right. So, now, ultrafiltration and reverse osmosis, they are both pressure activated membrane separation techniques. The major difference between ultrafiltration and reverse osmosis is in the pressure required to effect separation and the consequence, the results, what is it obtained afterwards, and the equipment and the pumping cost, right? As we've already seen from this picture on the previous slide. So what are the advantages of membrane separation? As you would see as we go along, the process takes place without phase changes, resulting in less energy requirements than those of the conventional processes do. So the material does not go maybe from a solid to a liquid or from a liquid to a gas. So the phase remains the same. So if you've got, for example, a liquid, it remains a liquid. So it means there is less energy required in your process, energy in terms of electricity and power and all those things. So since no heating is required in this process, the risk to heat damage to heat liable foods is minimized. So if you cook or if you're using high temperatures, you may result in burnt product, but this process does not require heat. It does not use heat. Aroma loss due to stripping of volatile substances is reduced because volatile components, they will not be lost. A large volume of cooling water that is required for cooling of heated foods is reduced, right? So because it's basically a cold process. This has cost saving implications since water is becoming very expensive. We know this with the case in point Cape Town. However, the disadvantage of reverse osmosis has over conventional method is the application of more viscous material. To overcome this aspect, pre-concentration of milk before evaporation is common. So basically that's a given. So reverse osmosis is used in the following operations: desalination of water, as mentioned, concentration of milk before evaporation or fermentation of cheese and yogurts. This process facilitates the concentration of solids and reduces the need for fortification. So therefore there is no need for us to fortify the milk with minerals, right? Or yeah, with other components. Reverse ultrafiltration, production of whey protein concentrate, brine clarification of cheese and processed meats, and also used in fruit juice de-ashing and clarification, also used in recovery of water purification for beer. So these are basically stuff that you can then go through, right? So thank you very much for listening. So please tune in to the next video. Don't forget to subscribe. If you've got any questions, please ask. Thank you. That was quick.